Hi guys, so this video is to introduce the triangle similarity theorems. So unfortunately, we do have one more round of proofs to take care of, but I'm hoping that I've simplified it enough to where you guys can still be successful, even though I know this topic is very challenging for a lot of you. So there are three different similarity theorems, and I've listed them on the screen, so I'd like for you to write them down. The first one is angle-angle, abbreviated AA. Second one is side-side-side, abbreviated with 3 S's for the 3 sides. And then the third one is side, angle, side. Now these might sound somewhat familiar to you because these are almost identical theorems to what we used in the congruence unit back at the beginning of the year. So these are going to be familiar to you, and they're going to work in very similar ways. So I'm hoping that we can draw some connections between what we learned earlier in the year to what we're going to use these theorems for now. So the first one is angle-angle. Now, angle-angle says that if two angles are the same, the third angle is also the same. This means that if 3 angles of a triangle are the same, we know the shapes are similar, right? One of the definitions of similarity is that all of the angles are congruent. 3 angles are congruent, then the triangles are similar. Now, the reason why we can decide really that the third angle is also the same is because we know triangles are supposed to add up to 180. So if these angles and the one that are missing add up to 180, then these two angles and the one that are missing have to do the same thing. These are the same. The missing are the same. This is just a neat little proof that I found on GeoGebra, so I'm just going to let that play and I'll kind of speak over what they're doing here. But the only thing that you need to write down from this slide is that if two angles are the same, the triangles are similar. Okay, so what this proof is showing us is this is one triangle and the pink one is another. So they're showing us how we can kind of transform these triangles and eventually translate corresponding corners onto one another. We can rotate the triangles for the other sides to line up. And we can dilate, we can shrink that other triangle to perfectly fit on the pink one that we started with. So this shows that starting with two angles that are exactly the same, right, as long as we line them up, line them up, then we can show that the triangles are similar. So angle-angle is one way that we're going to be able to do that. Another one is side-side-side. Now side-side-side is a little different than how we saw it before. Right? Before we said all the sides had to be exactly the same. Now, something about these sides does have to be the same, but it's the proportions of these sides that have to be the same. Now, remember, proportions are fractions. We're going to match up matching sides. We're going to match up corresponding sides, AB and DE. Now, that ratio will be the same as if I matched up another pair of sides, BC and EF. Right? These ratios are the same, that means it's a proportion. If all of the sides are the same in that way, if all of the sides have the same ratio, then we know the triangles will be similar. And the third one is side angle side. Now this one says if two of the sides are the same proportion, so we don't need all three, we just need at least two of them. And this is important, it has to be the included angle that's exactly the same. So the sides have to be in proportion, the angle has to be the same. Now, keyword here is it has to be the included angle. So if I picked sides AB and AC, the angle that's included between them, the corner where those sides meet, would be angle A. So if angle A and angle D are the same, and the sides kind of around them are proportional, we can say that the triangles are similar. So my question to you is, are these triangles similar? So let me exit out of this for a sec. Are these triangles similar? Oh, that's going to work. So I can see that one of these angles is the same, right? One angle is the same. Is that enough? No, no. We need at least two, right? For angle, we need at least two. Now, I do have a 45-degree angle and a 35-degree angle. However, I know these aren't the same, but that doesn't even really matter. These angles aren't corresponding to begin with. So I gave you a little hint down here. Use triangle sum is 180 degrees to help you find the missing angles. So if I focus in on this triangle, I have a 100-degree angle and a 45. So far, I have 145 in there. How can I use that to find what's missing? Well, triangle should be 180, and I only have 145. So if we subtract 180 and 145, that tells us that this missing angle is 35 degrees. Now what I have is I have two corresponding angles that are congruent. So this answer would be yes. These triangles are similar by angle similarity. And the symbol for similarity that we're going to use is this little squiggly line. Kind of looks like the top of the congruent symbol, but it's just the squiggle. So let's move on to another example. Oh, perfect. Oh, there we go. Now, I want you to pause the video and write down this whole chart, exactly how I have it. All the letters, all the symbols, all the statements, the names, because this sheet you're going to reference back to every time that we need to do special examples of these similar triangles. So what I mean by that is, whenever I see a stack diagram, there are two options for angles that I can use, right? If I know that the sides are parallel, I can use corresponding angles. This is the key up here, right? If I know that things are parallel, I can use corresponding angles. If the diagram looks like a bow tie, and I still have those parallel sides, I can use alternate interior angles, and I tell you where each of those are. But if I start with something parallel and the diagram looks like this, here are some angles that I can get. Now, if the diagram looks like a stack diagram, but I don't know anything about things being parallel, I can still use the reflexive property for a shared angle, right? Angle C is tucked away, not only to this small green triangle that I just traced over, but also this bigger one, right? Angle C is still the top of that larger triangle as well. So it's a shared angle, reflexive angle. If the diagram looks like a bow tie, we always know that vertical angles happen right at the middle there, in the middle of the bow tie. So I can always name those as a pair of vertical angles that are congruent. So copy this down into your notes. At least this needs to be in there, guys. It's really crucial, and it's going to be a great reference tool for you. If we were in school, I'd have copies upon copies of it printed out because it's that great of a thing. So I'm going to go through some mixed practice. There are two slides of it in here. I'm happy to go through one, and then I can make another one if you guys feel like you need it. But in the first section, what we're trying to determine is whether the triangles are similar. So if they are, we have to state the postulate or the theorem that we used and write the similarity statement. So all that means is, based on what we have, can I say that these triangles are similar? If I can, what's the reason I'm using? Now, in this first example, my two triangles have a right angle. In another pair of angles, however, again, guys, they're not corresponding, so I have to do some solving here. To find the missing angle in each triangle, add up what you have. 26 plus 90 is 116. Subtract the total from 180. So what is 180 minus 116? That is, I'm doing some mental math here, 64 degrees. Awesome. Gotta do the same thing in the other triangle, right? I want to make sure that all my angles match up. I have a 64 and a 90. Add those together, 64 plus 90 is 154. Now, triangles are supposed to be 180, so if I subtract 180 from 154, I get that this angle is 26. So for this first example, the answer to whether they're similar or not is yes. I have all congruent angles. I have at least two of them. So yes, by angle, angle. Now, this second example, I have three sides. Now, I have three sides, so it might be side, side, side. Question is, are my sides proportional? Is the scale factor consistent for all of the sides? Now, the scale factor for the two shortest sides is 8 to 6. So is that ratio consistent for all of the sides? Is 8 divided by 6 the same as, let's look at the medium sides in both? Where'd my little pen go? Well, the medium side is 12. The other medium side is 9. 12 to 9. Is that ratio consistent? The third, 16 to 12. Is that ratio consistent? So let's think about what all of these things simplify to. 8 divided by 6 is 1.3. All right, well, what about 12 divided by 9? Same thing, 1.3. So far, those ratios are proportional. The last one that we have to check is 16 with 12. So what is 16 divided by 12? 1.3. So we're in really good shape because what I have here is I have three sides that all simplify to the same thing. Ratios that are equal are proportions. So this one, again, is similar. We're using side, side, side to figure that out. Now this last one is also kind of tricky. I'm going to skip over this one just so I can talk about these bottom two. We want to determine if these triangles are similar or not. Let me zoom in. Awesome. We want to determine if these triangles are similar or not. Now, what I know from this first diagram is that I have a pair of 52-degree angles. Great. One angle isn't enough, though. However, it is a stacked diagram, like I told you about on the last slide. A stacked diagram has two things for us to use. I don't know these sides are parallel, so I can't use that first box because I don't know that things are parallel. However, I can use this box right below it. The box below it said that I have a reflexive angle where the two triangles meet. Two triangles meet up at the top over here, right? This smaller triangle and this bigger one share angle A. So I know that these two triangles are similar because of angle, angle. Didn't really look like it before, but I'm using that last slide, the chart on the last slide, to help me. And now the last one that I want to do for now, just because I think this video is getting kind of long, is I know that these two triangles have a pair of parallel sides. And it's a bow tie diagram. So here's what I know. I know that angle R and angle T are a pair of alternate interior angles. I also know that angle S and angle U are the same thing. They're another pair of alternate interior angles. I got this just from looking at the diagram. I had something parallel, it was a bow tie, alternate interior. I also could have used vertical angles that happen at the center there. No matter what way you cut it, angle-angle similarity is what's going on here. Again, I'm happy to continue the video if anyone would like. I'm going to hold off on doing these, but I'll leave the screen up, and if anyone would like me to do them, just send me an email and I'll pick the video up where this left off.